4, right? Okay, so the question is asking us to define velocity, right? In simple terms, velocity is the rate of change of displacement, rate of change of displacement. That's how we define velocity, change in displacement per unit time. Right, we have a student here. The student throws a ball over a wall, a vertical wall of height h as shown in fig 2.1. Alright, I'm sure you can see that this is a projectile, good people. The ball leaves the hand of the student at a height of 1.2 meters above the horizontal ground. The ball has an initial velocity of 22 meters per second at an angle of 40 degrees to the horizontal. The hole is a horizontal distance of 36 meters from the student is right. Air resistance is negligible. Okay, that's very key. Each time when you're dealing with projectile motion, you have to assume that there is no air resistance. All right, determine the time taken for the ball to reach the wall. All right, what is it that we're given here that can help us to find the time to reach the wall? Right, so the horizontal distance is 36 meters. That's how far the wall is from the point of projection. So that means we are given the horizontal distance, which is probably, we can treat it as the range, right? X at any given point. X is equal to ut cos theta at any given point. So this is equal to the initial vertical launch velocity is 22 there, and then we're looking for time. We don't know t. X is 36 and we have cos 40 degrees. That means our t is equal to 36 over 22 cos 40 degrees. Right, what do we get here? Right, 36 over 22 cos 40. Right, I'm getting, right, this is 2.13612, right, which is approximately equal to 2.14 seconds. Right, that's the time to reach the wall, 2.14 seconds. All right, let's see what's the next question. Right, calculate the vertical component u of the initial velocity of the ball. Remember, the vertical component, we call it uy. Uy is equal to u sine theta, the vertical component of the velocity. So this will be 22 sine 40 degrees. That gives us how much? Right, 22 sine 40. Right, this is 14.1413 and so on. So that means your u there is 14.1 meters per second. Right, we are told that the ball just goes over the wall. Calculate the height of the wall. Right, this is quite interesting. So let's go back to the diagram. Right, let's go back to the diagram. Okay, so what we have here, we already know that this is right, 1.2 meters there. Okay, so what we don't know, we can actually draw a line there. We don't know this height, which is x there. Right, we already know that the time taken to reach this point is 2.14 seconds. If you check from the first calculation, that is 2.14 seconds. So that means we need to find x there. I'm treating it as x because that's the unknown, but otherwise maybe we can use h or y there. Let's use y. Y will be ideal to find, right? So for us to get that height, we are going to use that equation, right? Let's go back down there, right? Y is equal to ut sine theta minus half gt squared. So this is going to give us, we already know that the initial vertical component is 14, so this will be 14.1 for u sine theta, and then times t, which is 2.14 minus half. G is 9.81, then the time taken is now 2.14 squared. So what do we get here? So this gives us 14.1 times 2.14 minus half of 9.81 times 2.14 squared. Right, this will give us 7.711106 meters, right, which means h is equal to 1.2 plus y, which is 1.2 plus 7.711, right? You can leave it to 3sf there. For sf, right, this is going to be plus 2.14, so plus 1.2, right? This gives me 8.911 meters. That's approximately 8.9 meters. Okay, so I hope we got this one right. Okay, so see you in the next video. Right, bye.